Cette présentation sera en anglais. Et oui. Hello everybody. I'm going to start. While a few people settle down, it's just a quick, what will we talk about today? So that if this isn't to your expectations, you can run away now. All right, this talk is based on my own work experience with my last customer. We're going to have high-level concepts about building a smart shopping cart app. We're going to learn how to think about machine learning and how to augment a traditional app with machine learning. We're going to get familiar with machine learning tools such as Jupyter Notebooks. We're going to look at the basics of training data sets, how to fine-tune a model, how to work with existing models, fine-tuning TensorFlow, a little bit of TensorFlow, a little bit of TensorFlow Lite, a little bit of Keras, although I don't even call it out by name in this talk. We touch on uses of OpenCV in the context of machine learning, and I'll also share some of my experiences using Perfetto to optimize a production app that uses these technologies. So, you've been warned. All right, so who am I? My name is Etienne Caron. I'm the technical founder of a company called Canastruc, based in Montreal, Canada. Technical founder, I'm going to share something here. I agonized over that title a little bit. It could have been, something like Ninja Village Chief or Pirate Captain or CTO, all which sounded equally pompous and over the top, right? So I went with technical founder because I'm technically a founder, but I'm also a technical person, and that's the first and foremost thing that interests me. So I'm a bit less of a business person than a techie. All right, so why am I here? Well, I love technology, as I hope most of you do, and I love sharing what I've learned about technology with people. And I think that's typically what we all have in common in these conferences. So I do a little bit of self-intro here just so that you know where I'm coming from. So if we see each other in the corridors later, you can ask me questions if you're curious. Started my career in '97, been there for a while. Very early on, I basically moved to Java backend development. I worked for a company called 8D Technology in Montreal, one of my career highlights. They were the people behind Bixi, if you know the bike sharing system in Montreal, but also the New York City bikes, London Cycle Hire, which probably went through a different name change by now. A lot of these bike systems are built by that company, so if ever you've seen one, they have a typical shape. You know that somewhere in there's backend code that I'm responsible for. Hopefully it didn't bug out on you. I worked a couple years here in France and Paris for RTL, Radio-Télé Luxembourg. And back in Montreal, I also worked early to 2010s for a company called Nuance. If you don't know Nuance, they're typically known for their products. Dragon Dictate is a thing. It's kind of old. Lots of text-to-speech, lots of natural language processing before it was a thing. They were secretly the technology behind Siri, so you've heard probably of them a little bit. So by now you're probably thinking, yeah, he's been around, cool. What else can he talk to us about? Well, I do know a little bit about Android as well. Benefits of age, I started very early with Android in 2009, where I built my first app for Vélib, funny enough, to track where the Vélib stations were empty before that was a thing. So that was kind of a cool project. Fast forward a few years, my first serious Android job is when I joined this startup called Passwordbox in Montreal in 2013 as their Android team lead. When I joined, a little bit of bragging rights here, we had a 3.9 star app with a few 100,000 downloads, which was nothing to sneeze at. And take it forward a year and a half later, we were at 4.5 stars, million downloads. Champagne, woo, really cool, lots of fun. A year after that, we got sold to Intel. We were bought by Intel, which, a successful exit is always exciting in the startup world. It also means that your business model probably wasn't working out. So, anywho, after that experience, which was really lovely, I joined a small Canadian company called Shopify. Quite a lovely experience there too, fun projects. My highlights there were working on this project called Hatchful. It was the perfect prototypical, you do the design startup phase, you do the design process, sprint, with your whole team. Everybody's there, your product manager, everybody hand in hand. We had the designer of our own. We had an iOS developer, we had backend people. Everything developed all at once. It was a project that lasted something like 7 months, and then very quickly 4.7 stars on the store, millions of downloads, super hype experience. Uses Firebase in the back. If you have any questions about Firebase, I still love Firebase for a lot of cool stuff that it brings to the table. Anyway, then switched over to the Shopify admin app. It's probably what you imagine. You manage your store, products, inventory, all of that. Worked with the core framework team there, staff engineer. Nice experience, pretty standard business type stuff. Then I left when Shopify switched to a focus on React Native, because my specialty was not really going to be a specialty anymore, right? So I fast forward like about a year after I left Shopify, I started my own little consultancy, which I've already touched on. And now the fun stuff. So I talked about this project last year here at Android Makers. It was a nice success. So I'm like a little reel video of the finished product. If you're curious and you were there last year, we weren't that far along when we presented here. So kind of wanted to show the demo reel from that. So this was a remote controlled from the F1 site with a little phone video conferencing. You can control these cars remotely, which themselves had an Android device in it, controlling a small microcontroller, and it was a lot of fun. So yeah, that was a fun project. I'm going to touch on it a bit later again, because there's actually some learnings from that project that carried over to my current project, which is the subject of today's talk, my last customer, Instacart. So for the little story, Instacart in 2021 bought another company called Caper AI for $350 million. That was like quite the successful exit for those people, really nice. The company's business was to make shopping easier and quicker by using smart carts that help you skip the checkout line, right? I think nobody's really finds this product probably mysterious. You probably all get the idea. You have a cart, you just do your shopping and you're done paying at the end. Basically like having those self-checkout counters, but on wheels, right? The goal for Instacart was sort of mix. Instacart, if you don't know it, because I'm not sure they're very well established here, they basically are a grocery on demand. Think Uber Eats, except for your groceries. So you call in with your order and somebody delivers it at your house. The Caper team back then for that cart actually had deals going on with in the US, Kroger and Wakefern, Sobeys in Canada, and companies that you know here like Auchan in France and Spain that had prototype carts. So you might have even seen these carts in real life. So I contracted with them to work on the Caper cart starting in June 2023 after the Formula One Bell project. And for autumn to spring of this year, my main concern was working on their camera subsystems, and I provided Android support to their big computer vision team. So today I'm sharing my learnings with you on that subject. So, quick tour of how the cart works, because it's kind of critical to sort of getting what we're doing. So these carts have an integrated scale at the bottom that allows you to track product weights. In the cart that picture above, that specific model, you have no less than 7 different cameras installed. You have 2 on the sides that look outward, 4 in the basket, and there's an overhead camera connected directly to an Android tablet. And there's also, for lighting and user feedback for the camera lighting, you have 2 big RGB LED bars included in the cart. If you put in a product and it scans successfully, they flash green to let the user know that everything is fine, that kind of stuff. So if we switch perspective, we see inside the cart, the first-person view. So you can see the second LED bar that wasn't shown in the picture previously. You can see the payment terminal, and you can see the actual Android tablet. All right, so as a consultant, and since Instacart is no longer my current customer, I have to be sort of careful about keeping some level of confidentiality. And to be frank, it's actually a bit more interesting to just, as a thought exercise, start sort of from scratch and just apply what I've learned. So this is a well-informed piece of fiction from now on. So we're going to build our own shopping cart. So what hardware do we need? We need an actual physical cart. We need a digital scale. We need LED lightings. That's a given. Batteries and charging, not negligible. And an Android tablet. And now these little icons that you see here are sort of, I wanted you to think through the presentation. These are the input signals that we're going to be working with as we go forward. Cool. So with a fantasy cart, we need a fantasy checkout application. So I'm not going to go over each screen one after the other. I think you probably have a decent idea of what these do. We'll touch on each of them as they're relevant. But I will start with the top level thing, right? You have a basket app. So that's where on the left, for example, you'd have all the nice promo marketing stuff. I touch on that because you might be wondering, why do companies like Instacart want to have carts in store? And one thing that is not secret that I can share with you is marketing is a really big reason for that. They can start selling ads. So Coca-Cola and PepsiCo can actually approach the company and say, oh, we want to put ads straight in the consumers' faces. And that's actually, a very nice and lucrative concept. Right, anyway, so on the right, the more technical functional part of the app is the place where every new product that's detected will be listed, that you get the subtotal price, and that the user can decide to, check out or call for help, or in the specific case that interests us today, add produce to the cart. And when I talk about produce, I mean bananas, apples, cauliflowers, anything that you need to effectively weigh before you know the price, right? So, barcodes are one thing. If you get your barcode scanned, that's cool. That's really easy, right? You can just get whatever it is, new signal detected by the CV, it adds the product to the list. Then we can move on to the checkout screen. Checkout screen, well, total is there. Effectively, that's where you review the total, you press your pay button, and everything is good, right? Thanks. Cool. That's the end of the golden path. But you can't only rely on a barcode that you're reading. And this is also pertinent for produce, so don't worry. You need to worry about something that people in the industry call shrink, right? Because it's not very polite to call your customers thieves. The basic idea is that you want to double check the weight of things that are being added to the cart, so that you don't only rely on whatever the barcode detector has seen go through the camera, right? So here I'm just showing this idea with the marble diagrams that you're familiar with if you've worked with reactive programming, where what you want on the system is to pair up a barcode with a weight change event, a stable weight change event, but I'm not going to get into that rabbit hole right now. And then once you get those two things together, you would effectively get a signal that says, hey, we've added an item to the cart. So, that said, the scale is obviously useful for produce as well, right? So the thing is that there's not only produce in life. The kind of things that can happen with the scale are basically unknown scale events, or a thing. What does that mean? Well, it's when the user is a bit too much of in a hurry and just puts something down in the cart without necessarily telling us what it is first. In some cases, it's a personal item. It's your purse, it's your bike helmet, whatever. In other cases, it's something that we want to bill you for, produce, right? So, produce. So many clicks. It's a bit of a mess. First concept, right? So you're in the main screen, you're in the basket screen, and ideally you don't want these orphan weight events. You sort of expect the user to be a nice behaved user and press the add produce button first. Right, and so with that, we know that we need to switch to the produce search screen. And that's already one click, not a big click, but we're already asking the user to do work. And then at this point, you're telling the user, okay, well, tell me what this is. So the user types in the code that they see on the produce, or if it doesn't have a label, very often they'll start typing the name of what it is, bananas. Bio, fair trade bananas, whatever. Right, you're gonna have a lot of things. So by the time you're done with this, you've interacted with the keyboard easily, dozens of times, or 8 dozen of times. And then you finally get to the last ask, which is, okay, now add your apple to the cart and please put it down, right? So you've been sort of holding produce, typing, annoying, right? But by the time you're done, you have the final wait event. Cool, we have the full flow, we've added produce. So a lot of work. What's a solution? What could we do to improve on this, right? Well, you probably know, since you know what the title of the talk is, but we're thinking about, okay, we're going to use camera frames to try to first maybe automatically detect that the user is adding something before we get a wait event, right? That's one way to go. And that's not so difficult. You don't even need machine learning to do this. You can use OpenCV. So you could use the OpenCV background removal tools to sort of effectively detect that there's something new in the foreground that's been added. So we see the little, sort of idea there. And then once you're done with that, it's not really enough on its own to just say, okay, I've put the user in the search screen. You'd probably want to be able to sort of say, okay, what exactly is it I'm looking at? And that's where you want something called an image classifier. We're going to get into that in a minute, what exactly an image classifier is. But it's that model that should help us identify not only that something's been put in, but what kind of thing is it to start with. But going back to OpenCV for a second, I wanted to show how the background removal kind of works and looks like. So this is like screenshots from an application, a small test app I wrote and I filmed earlier today. So the idea is that whenever something changes on the screen, these OpenCV tools remember what previous frames were there. They give you a delta and they just show you effectively what has changed and remove the background away. In case of a cart, if you remember the first-person view, you don't want to see the basket of the cart. You want to see the apple that's been put in there, or that's like being put in and it's showing in front of the camera. So you kind of want to just see, the action and not the rest of the stuff. All right, so how do you get into that? So I don't have a whole lot of Android code today. I rarely hear people sad when I say that. I feel the energy perks up when I say I don't have too much code usually. But I do have a few slides. I'm not going to talk about Camera X today, as I think I will touch on in a few minutes. There's other talks that are going to do a good job of that tomorrow. But one thing I do think is super fun about Camera X, which I did not have the luxury of working with at Instacart because we were on camera 2, is that you can set up the camera pipeline and give it a handler for the final processed image. So what's fun here is I can tell it I want a certain ratio of an image, I want this image in a certain RGBA format. All those are things that, if you can take care of them in a nicely tight way, it's really cool to have that handy. So image analysis right there is like a nice little tool. And you can see at the bottom in the last lambda that I'm passing in through the also function there, I'm setting an analyzer right there. So that's the code that's going to be called on each new frame. At the very bottom, you see this detect objects function that's just getting a frame. So it's a nice way of abstracting away the camera from the problem that interests us, which is like looking at frames and trying to detect stuff in them. Then I'm going to touch quickly on OpenCV. So what's fun nowadays is that you can get a prepackaged OpenCV version. If you've worked with OpenCV before, very often you have to download OpenCV, build it from C-source. It's a bit of a pain, and in the CI toolchain, it's not something you want to deal with necessarily. So here you can see the QuickBird Studio version of OpenCV is the one I recommend people using. It's the one I've had a good track record with. You just add it to your dependencies, and the one thing that you do need to remember to activate this kind of stuff is to have an init block somewhere with a system load library call to make sure that this native library is indeed activated in your project. Once you have that going for you, we can look a little bit at how background subscribers or background subtractors are actually built. This is a plethora of different choices that you can get from OpenCV. I'm pretty sure I'm not covering all of them. They all have like different little behaviors. Too much for this talk. Effectively, just remember that setting one up is fairly simple. It's a one-liner, unless you decide to give it a few more parameters, which you are free to do if you want, better behavior. Which is what I did in my own background removal code that we see here. So here the operations that we're seeing is that we're taking the original image, the image proxy that the image analysis is giving us from earlier, and we do just a couple of operations on it. First, we turn it into a grayscale image after having it copied from the buffer. That's important to keep in mind because these operations are not free. And then once you have your basically grayscale matte, your conversion from a bitmap to a matte, which is what OpenCV works with when they work with images, you can call your background subtractor, in case here after all those little comments, and you will get a foreground result. That foreground result is what I was showing you earlier in the screenshot, which you will get and you can work with. And so if you're processing things that way, you can use this OpenCV change detector to sort of only extract the colored pixels that have changed in the picture so that you would only, for example, see an apple before you send it over to an image classifier. Again, why is that important? You need to match what's going in there so that you make sure that you know, whatever's added is not wine, it's actually bananas, right? Cool. So, image classifier, I have to say a few more things about that. So, what's an image classifier? How does it work? What's our ideal situation? An image classifier, very simply, should be a function. You give it a bitmap, and it tells you something about that bitmap. Ideally, you want to know it's an apple, it's a banana, it's a potato, etc. Something to note about image classifiers is that they take the picture as a whole, right? And even though we remove the background, if it sees a few other things, it's going to take the most prominent feature in that image and tell you what it is, which is why it's kind of important to cut out the background, worth mentioning it. So anyways, this is a fictional function. What does the real stuff look like? It's a bit more complicated, but if you pay attention, the real call is at the end. Everything else is just a little bit of setup, which I'm not going to go into here, but this is effectively boilerplate code. So the classifier's job is pretty straightforward. Cool. Building it is a bit different. So how do you build one? How do you make your own? Well, first off, you need a large, preferably large, labeled data set, right? And you're going to use that data set to train an ML model of your choosing. In this case, we chose something called MobileNet V2. Why? Well, because it's one of the, there's a ton of models out there. You have model gardens, as they call them, where you can pick and choose whatever you want. MobileNet V2 is the one you're often going to see in mobile because it's designed to be small, effective, performant, and it's effectively designed for mobile. Then, what else do we get? Well, out of the box, Mobile VNet 2 can actually classify already 1,000 different types of classes. But we want to fine-tune this thing by repeatedly showing it the types of images that we care about, right? So by fine-tuning this model, it's going to tell us about what we want to know. If MobileNet V2 is able to recognize people in the street, we don't care about that, right? We just care about produce. So after we train that model, we're going to have to use a portion of the data set that we talked about earlier that wasn't part of the training set to validate, you know, the results of our training, to make sure that our model understands and recognizes the things we want it to recognize. Once we have our fine-tuned model, it's going to be a TensorFlow model, so we need to have it shrink down so that it actually fits on the mobile device. Cool. Another slide in here. I'm not sure people are actually going to ask me this question, but I could see it. What about LLMs, right? I've seen ChatGPT. You can give it an image. It's going to tell you what's in there. So are we not talking about LLMs today? It's like the sexy new thing, right? And while you do get LLMs and generative AI on mobile devices that run in TensorFlow Lite, it's not appropriate for the kind of work that we're doing right here today. You know, what we want is something that can work with 15 frames per second, 30 frames per second, really, really quick in inferring stuff. And if you've ever worked with images and ChatGPT, for example, or Gemini, you know that, you know, sub-second response times is not where you're going to get. All right, cool. So I'm going to try to fly through a few of these things, but today we're going to work with Jupyter Notebooks a little bit. Before we do that and build our own model and fine-tune our own model, I should mention that there's easier ways of doing this. So if you've been here in the room before me, there was Paul was here talking about MediaPipe. MediaPipe is a really valid and easy way of training models, fine-tuning them a little bit. The thing that you don't get is maybe as much as the fine-tuning that we're going to look into and a bit less of an understanding. But the thing that you do get is like a really quick way of picking certain models off the shelf and working with them in your use case. Another talk that I touched on earlier that's super interesting and that's coming up tomorrow is Walmir's talk. He's going to be looking more in depth into the camera X usage. I didn't actually ask him, but he does mention this in his talk description. And he's going to be talking probably about less setup stuff and more sexy stuff like AR alongside MLKit and MediaPipe. Should be super interesting, but I just wanted to point out that this is a talk you might want to look into if you find this one interesting, but maybe, you know, produce is not the sexiest subject in the universe, but, you know. All right, so back to Jupyter Notebooks. How does it work? What is it exactly? You can install it on a local machine. I typically recommend people should use cloud versions because you don't need to worry about the setup. You don't need to worry about Python versions and environments. And anyway, I've tried to set up my own environments. Every time it ends in tears. Online is really nice. A few of my favorites right there. I quite like Datalore, which is JetBrains' semi-paid solution. You get access to the usual ID shortcuts and all of that, so that's nice. The other one I recommend you check out is Google Colab. I haven't used it that much myself, but I do think that it's quite nice as far as the setup goes. It usually has like a nice setup of libraries, so it's a good one to check out. And the one I've worked a bit more with is Kaggle. So Kaggle is nice for a few reasons, but the big one for somebody starting out like me and maybe you is that if you haven't done a whole lot of this stuff, Kaggle is a community. There's a lot of, it's like a bit of a GitHub of machine learning, if you will, right? So you not only get notebooks with machine learning models being trained and all of that, you do also get a lot of really nice little data sets. So for example, my own process, at first I was looking for something that can recognize fruits and vegetables, right? If you notice, the first pick at the top is exactly what I wanted. It's a mobile VNet 2 fruit and vegetable image classifier. Cool, click on that, go see what it looks like. Now, if you scroll through, when I discovered this, that, oh, this is like a modern example with TensorFlow, Keras, all the things I actually wanted to play around with for various reasons when I was doing my research. Those things came up. So I'm like, wow, that's awesome. And not only that, but I noticed, oh, wait, there's like a data set with this. And boom, like a fruits and vegetable image recognition data set. We're going to touch on that later, but data sets are actually quite difficult to build and can be quite expensive to put together. So to have one already ready for training purposes and learning purposes, really cool find. And then you can sort of navigate through like, oh, who else is using this? Who's the first person there? Yeah, the model I picked the first time. So I'm like, okay, of all the users of this data set, I see that one of the more popular ones is the one that I already sort of selected out of the group. So that's cool. Kind of confirm that this is the right way to go. Right, so just notes for yourself if you're experimenting with your own subjects. Search in there, and then when you're done, you found a model that you like, a notebook that you like. You press copy and edit, and you just like off to the races. Right, cool. At this point, what's time like? I'm gonna fly through my slides. Originally, I wanted to live scroll through this stuff. I have like a few notebooks running, which I will share later. Hopefully I can find a way of sharing it with you all a bit later, but I'll fly through the slides just because it'll be a bit quicker and save us a bit of time. So a few notes, how these things are built. So the thing to remember with a notebook, if you're not familiar with them, is that whenever you write a cell of code, you can execute it right away and sort of get a feel for it. If by some miracle I end up early in this talk, I'll pop one open and show you a bit of a demo of that. But I'll just go through the different stages of what you would look for if you're creating your own and fine-tuning your own model. First off, there's always like this long import section with all the different things that you need in your project. I just talk about that briefly because in some cases the notebooks don't have all the dependencies that you need installed in the Python environment. So that's something that you want to sort of pay attention to before you get started and you start getting all sorts of weird error messages. Take a little look at the imports, make sure everything is there. If it's not, take the time to set yourself up right. It's going to make things much simpler after that. Then we talk about data sets first thing, right? So I'm hoping that this is legible. But effectively, when you have a data set, data sets are split in three different parts. You're going to have the training directory in this case, right? In this case, the way it's sorted out, all these images are themselves in separate little directories that indicate what label that we were working with. So if you look at on the right, hopefully you can see this, but each of the folders are named for what kind of pictures you find in that folder. And that's actually going to be the label that we're going to use in our training. The training directories are what you'd expect, like stuff that the model will look at to understand what it's looking at. Then there's a validation subset. That validation subset is to self-validate during training. We'll look at how that works in a minute. And the last very important folder is the test directory. So the idea when you're using a data set and you're building one, you want to make sure that there's a 10% of your data that has not been shown to the model, so that when it's time to test that the model actually understood and has properly trained itself and fine-tuned itself, you need to have something neutral that it hasn't seen before to see if your work is any good. You're trying to avoid something called over-tuning. Not the proper term, but effectively what happens if you overfit your model, it will look at your training data and always gives you like the perfect answer, right? Like this is an apple, this is a tomato. But if you train it too far and start showing it stuff that wasn't seen before, it's going to start losing the plot. There's a point where if you overtrain it on what it has on hand, it'll get really bad at real things that come from the field. So it's always that kind of balance that you're trying to work with whenever you're fine-tuning stuff. And we'll see how we can actually pinpoint if we're doing a good job, because there's a lot, well, you'll see in a minute. Anyway, so as part of this whole thing, preparing your data sets, you also want to sort of get a good idea what type of data you're processing. So there's a few examples here in this notebook of looking at the folders, looking at the amount of images, making sure looking at what kind of labels you're working with. So as you're sort of processing through your data set, you want to put out these statistics so you can take a look at them and say, okay, I have 36 different categories. And then if I look at this graph right here, they all about have the same amount of images. They're not equal, but there's like a roughly equivalent amount of training data for each of these. So this data set probably, is going to make sense at the end of the day. Once you've sort of done that, then you do there's some internal things that you need to do. In this code right here, you want to build data frames with your data. Data frames, they're a data structure that's provided by the library called pandas, which is very much often found in a lot of those notebooks. And it's designed to handle tabular data with ease, so it's effectively loading your directories and sort of formatting them in a way so that the rest of the notebook will be able to deal with effectively what were just like files on disk a minute ago, right? So the first thing you do before you even get further with these data frames is, again, you're going to check, do I have stuff that makes sense in there? So there's little samples of code. In most notebooks you'll find this, where you sort of print out a graph and look at the data. So here it's just looking at the top picture for each of the label categories and just putting them in a grid. So at a glance you see that, yes, it's an orange, and yes, these are kiwis, and there's nothing that obviously wrong with the data set right now. Moving forward, the data generators that were used to create that grid a second ago, well, we need to feed them into something a bit more complex called an image data generator. Those are kind of interesting, because if you think about training data, pictures are taken with a certain angle, but if you take, say, a well-centered photo of a banana and you move it by 5 degrees and rotate it, that's just as valid as an image for the training, right? Like, this is still a banana, and I still want the model to recognize this. So these image data generators, what they do is they artificially inflate your original data set by doing little things like jigging and zagging and rotating and doing little things like that, so that you get a lot more meat to give to the proper training model itself, so that it will be a bit more robust when you're showing it real life stuff. All right, cool. So our data is validated and augmented. We're ready to go. So we grab ourselves a copy of MobileNet v2. There's two important parameters really here that you need to sort of know about. There's one that's like weights equals ImageNet at the top there. And so that's actually telling the framework, hey, we want a MobileNet v2, but we want it trained with like the latest available weights that whoever got like the best results with previously has built. So you're getting a fully trained model on hand first. And the second one, which is important, is that since we don't want to recognize 1,000 different things, but only the 36 fruits and veg that we care about, we shave off the top layer. So I'm going to do some hand waving about neural networks and layers and things like that. All you need to know really about neural networks to be able to work with them as a developer is there's layers of them, and then typically the last ones you want to shave them off, and you'll find a very good example from most of the models out there. When you want to fine-tune them, you'll find somebody with a little sample that basically says, I take this fully trained thing, I shave off the top, I add these couple of like layers that I can train, and move on. So that's generally how you're going to work with a pre-trained model. And then to achieve this fine-tuning, the other thing that you need to know, besides just chopping off a layer and adding one, you need to basically tell when you're training, hey, all these previous layers, they're frozen, don't touch it, right? So that when it's training, it's not going to modify any of those weights and mess around with that layer of the network. We add our few custom layers on top, and then we get to a point where, again, you want to double check what you're doing. So you just use some standard summary methods that will print out what the layers are in the model. So if you know what you're doing, you can take a look at them and say, oh, I've done it properly. And if you don't, well, you can still go back there and debug whenever you hit a wall. So that's kind of the idea there. All right, so we're getting to the exciting part, the training. A few steps again. There's a compilation step. So you want to pick an optimizer that, like, there's a lot of things. I'm not going to go into the detail here, but effectively at this point, you're telling the model, this is how you should try to find the truth, right? Mathematically, you give it a few functions. Those things are well documented, and there's a lot to say about them. But you configure it by telling it, okay, this is how you're going to start, aiming towards proper results, and this is the mathematical functions that you're going to use to do this. The other thing to know is that there's a callback section. What's a callback? Well, it's something we're using in Android, but think that during the training, right, we're training in multiple epochs. The training is going to be super long, but there's a point where we can overtrain the model, as I mentioned earlier. What you want to do is tell the model in the callback, hey, if you don't see improvements for like 5 or 10 steps, then we're going to stop and we're going to drop the last 5 results because those were most certainly overtraining. And it's in the callbacks that you explain to the model while it's training how to do that. Cool. So actual training call. This is the part that takes ages. And the only thing to note here is like actually a very simple call. You pass in all the parameters that we've discussed a minute ago. Then, a bit more fun, you can, at the end of this training, which probably takes an hour or two easily, you can start looking at, okay, so how did it work? Like, what did I get as far as results go? And so you get these kinds of graph usually, and I'll explain them shortly. So the loss is, the idea is that lower is the better. It's like the least loss you have, the more close you are to the truth. The accuracy is how accurate are you at recognizing that a banana is a banana. And all of this is done with the training data and the validation data, not the testing data. So the lines that you see in red are measuring against the validation, right? So the blue is I'm training on this stuff and I'm getting good results when I change my functions. And oh yeah, I'm recognizing that banana is really a banana. But the validation set in red is effectively sort of the counterpoint to that. If you see at the very beginning, it thinks it knows how to recognize stuff, but there's these big spikes in the graph in red. So those are like the steps that the model is really crappy with anything that's not part of the training set. But when you start seeing those two things align, you know that you're in a good place. And when you start seeing the gains plateau, those callbacks I mentioned earlier will kick in. We'll say, okay, we're stopping this now. We're just overtraining. We're done. This is the model. Let's go. And once the let's go part is done, then you evaluate the model with the testing data. Here is just like a way of testing it and getting a final score. We're getting a test loss of 0.1 and a test accuracy of 0.97, which is pretty good. If you want to get a better feeling of how good that is, this is a full grid of all 36 fruits and vegetables that we can recognize. And the dark blue line in the middle is effectively when the match is perfect, when the model has managed to get the right thing and we're good. And you can see there's a few outliers where it thinks hot peppers are bananas. Probably they're like ripe hot peppers that are kind of yellow. But those are like normal, right? At some point, the model will not be perfect. If it was, you were probably overtrained. All right, cool. So I'm going to move on because time is of the essence. I'm going to move on to like one big key point. There's like a step where you can save your and convert your TensorFlow model into a TensorFlow Lite model. The code is almost insignificant. You'll find it everywhere. It's effectively just loading back up a TensorFlow model and saving it again as a TensorFlow Lite model. But what you won't see in some samples is that if you do not take the time to add metadata to your TensorFlow Lite model, it might not work in the Android code. When you load up a TensorFlow Lite model, you need to give it parameters in a certain way. And if the TensorFlow Lite model itself is not describing what it is expecting, then TensorFlow Lite, the framework in Android, might just say, I don't know what to do with this model. I don't know what to give it to get responses. So there is a step where you need to make sure to add metadata. And you need preferably, I would recommend you make an effort to note down or something that metadata writer is the API that you want to use. There's a few guides out there on how to do it. They're all long and really painful. This is the way to do things in about 5 lines of code, so I recommend you just, if there's one thing you should remember the whole notebook thing, like train things that way. All right, cool. Advantages of doing this long method over media pipe. Well, really at the end of the day is that you can load any data set you want. So if Kaggle has a data set, that's cool. You can import it. You can import between different things. Datalore is able to import from Kaggle. So that's like very flexible. That's a plus. OpenCV image manipulation of the data sets. If for some reason you decide that color matching images is not a good plan for you, right? Produce, not a great idea because what's the difference between an orange and a pamplemousse? Well, it's the color, right? So if you don't have color data, you're going to have a hard time classifying, I suspect. But if you're really looking to optimize as fast as possible something, you might want to train a model on black and white grayscale pictures. So those are things that you need to figure out when you're, depending on your use case, but that's one of the benefits of using notebooks to configure everything. And again, one last thing on that is that exporting your models in other places than TensorFlow Lite, or getting models that are not TensorFlow and exporting them in TensorFlow Lite, these kind of manipulations, some of the frameworks offer them, but if you have notebooks, sky's the limit. You can basically convert to anything. I have a short time left. I would like to touch on Perfetto. Yeah, I will touch very briefly on Perfetto and show you like the key learnings here. Sorry, I'm just like thinking through how much time I need to make sense of what I'm trying to show you. I'll keep it brief on Perfetto. There's like one real key learning that I want people to pick up from my talk, which saved my bum a few times. First, what is Perfetto? It's if you go onto the website, it's a trace analysis tool that lives in the browser. It's a local tool. It works with local traces if you're not aware what it is. Who here has not heard of Perfetto? And it's perfectly fine. All right, cool. So if you use the Android IDE's tracing tools, they're really great, but Perfetto really brings it up to a notch. So the way that you can use Perfetto, the first thing you need to do is like on the command line, you get the script from the Perfetto site that I was showing on the last slide, this record Android trace script. And when you run the command I'm showing up here, what's going to happen is that your ADB connected phone is going to start tracing for a number of seconds. Here in this case, minus T10S, I've configured it to trace for 10 seconds. When the process is done, it's going to dump this trace file on the local disk and automatically open up a web browser pane with Perfetto, and then you're going to get the full rainbow multicolor goodness that is Perfetto traces, that are Perfetto traces. And I will jump. One thing I should mention, the little minus A star right there is super critical, because one of the things with Perfetto it's something I ran into last night, and I wanted to share in case you run into the same problem. Perfetto traces allow you to create slices and to create blocks of traces in your code that will show up on the tool. But if you do want them to show up on the tool and you want to use this to sort of measure the time it takes to do inference, the time it takes to copy bytes from A to B, the time it takes to, all this good stuff, if you don't have the minus A and you have your traces, they won't show up in the Perfetto tool. So that's like a key learning that I got from, thank you, #performance on ASG, because without you, I wouldn't even be able to talk about this today. And then I will really rapidly, to end this, switch to, okay, good. I will switch to a few Perfetto traces just to show you what they look like at the very least, and what they look like when you manage to make the tool work the right way. Yes, I clicked on that by mistake. Never mind me. All right, cool. So the concept is that when you add in your Android code, come on, fingers, don't fail me now. When you add traces like so in your Android code, I'm going to try to zoom that in a little bit. When you take a block of your code and you lambda around it like this with a label, this will start creating a start and an end of a slice that will show up in Perfetto in any given section of the code you're interested in. So if you're doing an inference, and I'll jump back to the tool right here, and you see I have this top level one called image analysis. I hope it's sort of readable. Perfetto likes little fonts because it's showing a lot of information, right? But so if you look at the image analysis, the little hover tells you that there's 120 milliseconds for the whole inference for one frame. And then underneath that, when you want to start in analyzing where the time is being spent, then you can see, for example, that one of my traces is around copying pixels from buffer to buffer, which is kind of a slow thing as well. So you can see, okay, I'm spending so many milliseconds on that part of the process, so many milliseconds on that other part of the process. And I'll really cap it off at this because I think we're going to be on time. At the end of the day, what's also super interesting at Perfetto, which you won't get in the Android IDE Studio tools, is that you can start looking as well into the system's own activity. What I mean by that is that if, for example, you're working with I'm trying to find the right segment here. If you're working with a system that's sort of being constrained at the camera level, say your camera is working too hard, so to speak, you can start tracing your code into the calls of the system. So here we can sort of look at the camera providing services of Google and sort of look into, okay, how much work am I actually getting the camera to do right now? So if you need, for example, the cart was a big challenge because if you need to sort of take into consideration how much load you're putting on the whole device and make sure that the experience stays good, Perfetto is really good for that, to correlate your own code with the system code and see where things are going and what kind of work you're triggering for the rest of your app's ecosystem. All right, so I'm gonna just jump back to the slides. And how are we on time? Should I be stopping right now? Yes. So I'm gonna maybe have time for questions. I'm gonna just jump back to the slides and say a big thank you to you all for your patience. So thank you, thank you, thank you. Do we have time?